right, so when thinking about linear functions, a lot of us remember the very, very basic y equals mx plus b, if nothing else. Anyone remember what we call that? Slope-intercept form. We very nicely name a lot of these based off of what they tell us. So slope-intercept form literally tells us the slope right there and the y-intercept right there. Anyone have any other formulas that we remembered? Anyone remember slope formula? M equals, any recollections of this one? y2 minus y1 over x2 minus x1. There was one more type of line formula that we used a lot. This one's called point slope form. Anyone remember anything about that? Zero recollections. All right, so that one looks like this. This is not the form of a line that we leave a line in that equation. We will still solve that one for slope-intercept form, solve for y. But we use that one to get started on certain types of problems. And this one, again, is called point slope form. Again, we use the names of this to tell you what's in it. It includes any point off of the line as well as the slope. So, I like to make things nice and easy. Now, if you are given, in like example 1 right here, the slope is negative 2/3 and the y-intercept is negative 1, which of those formulas do we need to use? Slope-intercept form. Okay, when you are given the slope and you are given the y-intercept, all you have to do is plug it in. Those should be kind of your gimme problems, hopefully. That's not something that you have to think too much about. Now, we do have some specific types of lines that we've worked with other than just a basic linear equation like number 1. And those are horizontal and vertical lines. Okay, to do horizontal and vertical lines, you do need to know what they are like in order to set them up. Some of you do better thinking about them visually. For example, a horizontal line is any line going side to side, right? Anyone remember what kind of line or what kind of equations those would have? Just one number, and is it a y equals or an x equals? Y equals. So if it's horizontal, it is a y equals a number. All right, on the side here, in case we need it. If it's vertical, so if a horizontal is y equals a number, what's a vertical? X equals a number. Okay. Horizontal lines are basically like a normal line, only it has a slope of 0, so it cancels out the x in the y equals mx plus b. So if a horizontal line is just y equals a number, in this particular example, it's y equals which number? -1, that's our y, right? Again, no work, but you do have to know that information, okay? I will say for this particular unit, the question is always, what do I have to know or what do I have to memorize on my own? I do not give you formulas. So any of those formulas up at the top, that would be something that you'd have to pull out of your head. Or knowing y equals a number for a horizontal line, you got to know that or be able to figure it out. Okay? Now, on a question like number 3, when you are given 2 points, just random points, anyone remember where you start for those? Finding the slope. So that, going back up to the top, we're going to use one of our formulas, slope formula. Does it matter which point is x1, y1, and which point is x2, y2? It does not matter as long as you are consistent. In other words, if I make this my y2, then this has to be my x2. You can't pick a random y to start with and pick the other x to start with on the bottom. It doesn't work that way. So you can do, for your slope, -1 minus -3 over -7 minus 5, or you can flip both of those and do -3 minus -1 over 5 minus -7. Either way, you should get the same slope. Okay, remember minus a negative turns into a plus, so -1 plus 3, get 2 over negative 12, reducing our slope to negative 1/6. Now, this is where one of those other formulas comes into play. Slope-intercept form requires that I have the slope and the y-intercept. Do I have the y-intercept? No. How do I know I don't have the y-intercept? The y-intercept always has an x value of what? 0. So I look at my points, no x value of 0, don't have the y-intercept. Therefore, I cannot currently use slope-intercept form. What can I use? Point-slope form. Now, just like the slope formula, does it matter which point you choose? No, it does not. And those who are extra super special careful sometimes like to do both and make sure they're right. It's a little bit over the top, but, it's okay. Any preference as to which point we would like to use for this? 5, negative 3. All right, let's use that. So setting that up, using your point-slope form is y minus negative 3 equals, next comes my m, which is what we just found, and x minus 5. We don't leave it here. We go ahead and simplify and solve for y. That requires us doing what first? Distributing. Good. All right, so this would be a non-calculator question. Not that most of you think it's that difficult, but fractions make us all a little bit crazy. Remember when you were distributing that negative 1/6 to the 5? Okay, you multiply the tops and the bottoms if you need to think about that 5 as 5 over 1. Go ahead and do that so you can multiply the two fractions together. A negative times a negative does give me a positive 5 over 6. On the left-hand side, all I would simplify is that two negatives make a positive right there. And I forgot my x. There we go. Then to solve for y, what do we have to move? Subtract the 3. But when I subtract the 3, what am I subtracting it from? The 5 over 6. So you may want to convert that. Think about it as 3 over 1. What is 3 over 1 in terms of 6? 18 over 6. So you're really subtracting 18 over 6 from 5 over 6. So our final answer here, y equals negative 1/6 x minus what? (13 over 6). Good. Okay, we're going to get back into practice with fractions. I know how much we love them. We're just going to get comfortable with them. It's going to happen eventually, I think. Okay? On number 4, let me erase this real quick for you, and then we'll go to look at number 4. I'm just going to get you started on number 4 and see how you can go from there. Anyone remember the whole parallel to business?
No.
Parallel lines have the same what? Slope. Okay, so how do I know what slope that line has? Got to put it in y equals mx plus b first. So take a minute on your own. All I want you to do at this current moment in time is to take that and solve it for y. All right, so what did we get for y equals on this one? Anyone have a good answer? Y equals what? 3 over 4x. Minus 7 over 4. What part about that line do I care about? The 3 over 4. Do I care about anything else in that? No. I think that's the biggest mistake I see on these kind of problems, is that we want to do something with this. I often won't even finish solving, but as soon as I get the 3 over 4, I'm like, well, there's something back here. Who cares? This is what I care about. That is my slope. That is my parallel slope I'm going to use with this point. Now, think back to what we just did on the previous problem. I now have a slope, and I have a point that is not my y-intercept. Where do I go from here? Point-slope form. Okay, take a minute on your own. Put that into point-slope form and see what you get. All right, so check what you've got there. Any problems, questions, concerns? Not sure where I got something from. Oh, that's a good question. If I reduce that to 9 over 2, and I subtract 1 in terms of halves, that would be minus 2 over 2. Unless I reduced that wrong. Did y'all, okay, so let's go back a step. Did y'all leave this as 18 over 4 or 9 over 2? 9 over 2. All right. So let's just go with 9 over 2. So if that's 9 over 2 and I subtract 1, 1 in terms of halves is 2 over 2, right? Negative 9 minus 2 over 2 is negative 11 over 2. Yeah? Am I okay on that one?
You didn't know that you would have to make it 2 over 2. I think you should subtract 1.
Nope. You've got to have a common denominator in order to add or subtract. So in order to subtract that, you've got to make that a 2 over 2 and then subtract. Good questions. On the way through all of this, since this is our first day and we're all kind of quiet today, number one, if you have a question, ask it, please. It is like I'm getting back into this too. It's been a summer of me talking to preschoolers, so I may say some stupid things that don't make sense. It will happen. I'll write something that makes literally no sense, and I really don't want to make it through like a 10-step problem and have someone be like, I was too scared to tell you, but that's a 2 back up there. Just tell me. I'm not like easily offended at all. Sometimes I'm thinking about what I have to do next or the Zoom call or whatever else, and just tell me if something doesn't make sense, because I will make my mistakes here, for sure. And ask questions, because if you can't read something or you can't understand something, someone else can't either. That's definitely the truth. So, on the back, real quick, a couple more basic questions. And this is going to be the end of our notes when we hit number 10. So we are going to have a decent amount of time today to do some practice and get outside maybe and take a break. So we're going to do that today because y'all are going to have a long day. If I can, I know, we're all going to want to talk and all of that. If we can do this on a normal basis, get through the notes, we're going to do that. I'm all for the outside. This is not going to be a good situation long term. So we're going to figure out how to do this. We're going to get work done outside and give you homework time. If we have to take a quiz outside spread out, we might do that too. It's just going to be okay. We're going to be fine. So let's finish up our last couple problems, and then we will get outside for a little bit of practice. Anyone remember what kind of lines have undefined slope? Heard a bunch of different things. Undefined slope first is defined as any number over 0. Now, what particular types of lines have that? Anyone remember that?
Lines with undefined slope.
Yes, truth. Vertical. Okay. Honestly, the only way I remember this, undefined starts with a U that's real close to V. It's either going to be horizontal or vertical. The way I remember that they go together is that undefined starts with U, vertical starts with V. They're right next to each other in the alphabet. Horizontal has an O in it, which looks like 0, and that is a 0 slope for horizontal. I know that's a stupid way to remember it, but it works for me. So it might work for someone else. So we're looking to make a vertical line, equation of a vertical line with the same x-intercept as this line. Ooh, boy. Anyone remembered how to find x-intercepts? Set y equal to 0, yes. Good, I was hoping you did not say graph it and see, so good answer. The easiest way to find an x-intercept is to change your y into 0. Essentially what that does is just gets rid of the y term altogether. You get 3x equals negative 6. So the x-intercept of this line is negative 2. Now, what kind of, let's go think back to the front page. We said a horizontal line has the equation what? Y equals. Now we're looking for vertical line. Vertical line has an equation of x equals. Well, if it goes through that x-intercept, and it's the equation x equals. Anyone seeing what I'm seeing here? Do I have to do anything? No. This is both the x-intercept of the line that we were given and the equation of the vertical line that goes through it. Okay? So that line does go through the point negative 2, 0. It has that x-intercept. But the vertical line that goes through that point has the exact same equation as the x-intercept. So you really didn't even have to do any more work than that. Okay. Any questions about where we got that?
Will it always be like that?
No, it will not always be that way. This one just happened to ask about the x-intercept. It could say that it goes through the y-intercept or it goes through this random point. If it goes through a random point, it's just going to be x equals that number, whatever the x value is. Okay. Real quick, we're not going to use these often, but they are just handy to have and know. Also, SAT, ACT prep stuff. Distance and midpoint formula. Distance formula is this good old square root one. What is that one? Does anyone think this reminds us of another formula that we just kind of looked at? Looks a little bit, it kind of looks like the slope formula to me. Yes, it has pieces of it. It's like the slope formula combined with Pythagorean theorem. Okay? So that's your distance formula. Your midpoint formula is a set of points, actually. The midpoint formula, I don't even really memorize the formula that I'm writing down here. I'm going to run out of room here. That's really just an average, if you think about it. Midpoint, you're finding the midway between the two x's, the midway between the two y's. All you're really doing is adding two numbers and dividing by 2. Now, what confuses some people at the midpoint is that you are getting a point back out, an x and a y. So there's two parts to your midpoint answer, an x and a y value. Distance, you're typically going to end with a square root for this one. Okay? So let's take a look at the distance formula real quick. Again, it does not matter which one you label x1, y1, which one you label x2, y2. Just visually, we tend to make the second one your x2, y2, and the first one your x1, y1, just because your brain works that way. So we would do 7 minus negative 3 turns into plus 3. 2 minus 5. Remember, anytime you square anything, what does it become? What kind of number? Squaring anything, positive or negative. They're all positive, right? So in this case, I would expect you to go through in these kind of steps. 7 plus 3 gives me 10. Squared is 100. 2 minus 5 is negative 3, but when I square it becomes 9. Okay. Now, when we get here, we do tend to look for a way to simplify this. So first off, in this class and going forward, we're not a massive fan of decimals, especially if it's like a square root type thing. If something ends in a 0.5 or a 0.25 or what I like to call a nice decimal, very specific, right? A nice decimal that ends, for example, like a 0.5 or a 0.25. I'm okay with those. I still prefer the fractions. Square roots, we don't do those in decimal form, ever. Okay? If there is something that goes into 109 that you can take out of the square root, then do it. This one, I'll just give it away. It doesn't simplify at all. So you can leave it there. Okay? But if something's like a fraction that is a third, like 1/3, 2/3, any of that, those are the not nice decimals, the ones that just continue going out, out, out. We always want those in fraction form. So that's just kind of where we're going to go with rounding and fractions and all the good stuff. Midpoint formula, take a minute and do that on your own. Number 8. I don't think you really need me for that, but we'll check our answer in a minute. All right, any questions about your midpoint? All right, we're going to finish up real quick with systems of equations. So systems of equations goes with linear functions because one way of solving a system is solving by what? Elimination is one. Okay, what's another one? Substitution. There are actually 4 ways. Okay, so we've got elimination, substitution. What else? Any thought as to why I would put this with linear equations? Solve by graphing. We don't use this one often, but when you can graph both lines and see where they cross, That's another good way to solve it. So if you have a calculator, that's a great way to use that because you can solve for the intersection point. The fourth one, we tended to use in Algebra 2 only for systems of 3, but we're going to talk about it today as well. Systems of 3 equations or more, we used matrices. Anyone remember those? Vague recollection that was a word at some point in our lives. All right, we're going to start off with the first two here. Elimination, substitution. I'm not going to solve by graphing because if we're being real honest, that's not something that we use real often. We tend to avoid that one unless we're given a graph. So we're not going to solve by that today. Just remember that's like graphing both lines and seeing where they intersect. We are going to go over matrices. Okay? So if you look at questions 9 and 10, one of them is set up for elimination, one of them set up for substitution. Any idea of which? 9's elimination. And why do you say that? Okay, we're kind of trained with elimination to notice those two are exactly the same. One is 1y and the other is 1y. Therefore, if all I would have to do to solve this is subtract. Because your view on elimination, your goal is to try to eliminate or get rid of one of your variables so that you can solve for the other. If I subtract everything, x minus 2x, this gives me negative x. What happens when I do y minus y? They cancel. That's the whole point of elimination, right? 7 minus 5 is 2. Therefore, your x value is actually what? Negative 2. How do you find the y? Because when you're doing a system, your answer is all the variables. Plug it back in. Does it matter which one? Nope. Pick whichever one's easier. The first one looks easier to me. Therefore, I get a y value of 9. We write our answers to systems as an ordered pair, x comma y. If they're not x's and y's, just put them in alphabetical order. All right? Now, 10 is set up more for what? Substitution. Why do you say substitution? When one variable is already solved for, you already have y equals that. If y is equal to that, substitution says I go to the other equation, leave out the y, and in place of that y, put what y is equal to, which in this case is what? 6x. In the same way, you've now got yourself down to one variable, and therefore you can continue solving for your x. 3x minus 6x is negative 3x. Therefore, x is negative 2. Again, how do you find the y? Plug it back in. Now this one, typically, the one that's already solved for the y is the easier one to plug it into. So I tend to come back to that one. Okay. I know this kind of stuff is easy-ish for us. I'm showing steps. Even if this is super easy for you, there should be some work or at least setup on every problem. If you are turning in homework and that's the only thing on your paper, I'm going to assume that you did not solve by substitution or elimination, that you solved by photomath or what are our other favorites, Wolfram Alpha and the other online ones, or a friend. So just make sure you show some work so that I know what you are doing and why, especially on a test or a quiz. Tests and quizzes, I am a big partial credit person, but only if you show me what you're doing. If you're not showing me what you're doing, I can't help you out on any of those. Now, I do want to talk about matrices real quick. We're going to solve this number 9 again using a matrix. So if you do have a calculator, go ahead and get that out. If you don't, you can follow along with me on the screen. All right, so once you're in the matrix menu, second, and what is that button? I can't even see it. The X variable one? Okay. There are 3 different options here. It says names, math, and edit. The first thing you're always going to go to is edit. You're going to need to create 2 matrices to solve a system. You make a matrix out of the coefficients, which are the numbers in front of the x's and y's, and then you make a matrix out of the answers. So over here under edit, I'm going to hit enter next to A. First, you need to tell it the size. The size of this matrix for the coefficients is 2 by 2. This is because I have 2 variables, 2 equations. If I am looking at number 9 on this page, I'm just going to enter the numbers in front of the x's and y's. So I'm going to go ahead and put 1, 1, 2, 1. We all agree those are just the numbers in front of the x's and y's? Okay. Now I need to make an answer matrix. The only thing that I don't like about the 84s right now is that you're inside the edit thing and you can't get back out of it to go to another one. So the only way to do that is go second and the matrix thing again. Then you have to go back to edit. This time we want to use B. Now, for B, these are just the answers. You're going to call this a 2 by 1. All you're going to do here is enter the 2 answers on the right side of the equal sign. So for number 9, that's 7 and 5. Those with 84s, any problems so far? All right. Inspires, I'm going to get back to y'all. Sorry, you have to wait for a second. Now, for the third time, we go back to second matrix. Here's where we use the names. The names are basically just here's the matrix that you're going to drop into your calculation menu. So I'm always going to do A first. So I'm going to hit enter right here, and it's just going to drop A. Whoops, hang on. Did not want to do that, actually. So we would like to quit. Go back to the regular menu. We want to be in the regular menu. Second matrix. Now you want to do A. It's going to drop it into the regular calculation. You are always going to do A to the negative 1 power. And I just got rid of that again. I love this. A to the negative 1 power times, and then go back into your matrix menu, B. You're basically telling it to find the inverse of A and multiply it by B. But if you hit enter right there, it's going to spit out a matrix at you. Negative 2 is your x, 9 is your y. Again, that's a lot of work for a 2 by 2 that we solved by elimination like really easily. On your homework, you're going to have a couple 3 by 3s. Those are a whole lot easier to solve with a calculator. Okay? Now, Inspires. Let me drag that over here. Exit this. Inspire. So if you have an Inspire calculator where you are going to find your matrix stuff, you can find it a number of different places. The easiest one to me with the Inspire is if you go escape. If you just do the button next to the number 9, it has a lot of different things. I call it the templates menu because it's basically anything that you would want to find like a basic setup for. The matrices are these 4 right in here in brackets. These are very specific ones, the first 3. So this is specifically a 2 by 2. This is specifically a 1 by 2. This is specifically a 2 by 1. This third one looks like it's a 3 by 3, but if you hit enter, it's the menu that you can type in any number of rows and columns. So if I was doing question 9, just like the other people did, I would first make a matrix out of my coefficients. And I need to have a calculation menu here, excuse me. So I would go ahead and use that. I would type in my coefficients. The only difference with the Inspire is that you don't have to name these anything. You can just type the matrix in. Just like the 84s, you are always going to do to the...
The negative sign, like on the numpad?
Yes. You don't want to do the minus sign. You want to use the actual negative.
Oh.
Yep. And if you hit enter on this one, once you type in those matrices, so you always do the coefficients to the negative 1 power, which is the inverse of that, times that. It, again, just spits out an answer just like the other ones. And you can solve it that way. Again, I really only use these for 3 by 3s. Okay, you will have to know how to do this. This is kind of calculator stuff. So if you did not get through that or have no idea what I'm talking about, got lost in the way and didn't want to tell me, let me know, and I'm happy to help you. Okay. Before we go away from this, does anyone have questions on that? Okay, so it's just another method of solving systems.